I'm going to use substitution here in order to solve this system algebraically. What we look for with substitution is a variable by itself on one side of the equation. So you'll see here we've got x by itself on the left side of this equation for the first one, and x equals this negative, or this 2y minus 4. This is what x is equal to. So what we're going to do is we're going to substitute that in for x in the other equation. So I see an x in the other one, and I'm going to plug this 2y minus 4 in parentheses in where x is in the second equation. That will be 2 times that whole x thing plus 2y equaling 16. So that entire 2y minus 4 goes in place of where the x was in parentheses, of course. Then we're going to solve this equation for y. Multiplying the 2 in would be 2 times 2y, which is 4y. 2 times the negative 4 is a negative 8. And then bring down the rest of the equation. And then we're going to combine like terms and get y by itself. So 2 steps from here, adding 8 to both sides gives us 24 equals 6y, and then dividing by 6 will give us y. Y is equal to 4. Now, this is not the solution. We've got to make sure we find both coordinates, both parts of the coordinates, x and y. So we can take 4 and plug it back into either equation in order to get x. I'm going to plug it back into the easier one, which is the first one, x equals 2y minus 4. And I'm going to plug in just the 4 where the y is. So x equals 2 times the y minus 4. So that would just be 8 minus 4, which is 4. So actually they're both 4. So our solution is 4, 4, because the x-coordinate and the y-coordinate are both 4. On to the next one here. So in this case, we've got y by itself this time. So I'm going to take the 2x minus 26, and that's going to go in place of y in the first equation, because this whole thing is equal to y. So I'm going to replace the 2x minus 26 in where y is in the first equation. So that'd be 1x minus 5 times that, in parentheses, equaling the right side 40. This time I'm just going to solve for x. So take the negative 5 and multiply it in. So negative 5 times 2x is negative 10x. Negative 5 times a negative 26. So two negatives there are going to multiply and make a positive. That's a positive 130. And then bring down the rest of the equation, the 1x in front and the equals 40 on the right. Then combining our like terms would be negative 9x plus 130 equaling 40. 2 steps from here to solve for x. So minus 130 from both sides will give us negative 90 on the right, equaling negative 9x on the left. Dividing by negative 9 gives us our x answer, which is just positive 10. To get y, I'm going to put that into the either equation again, but I'm going to use the second one. So y is 2 times the x minus 26. So 2 times 10 is 20, minus 26 is a negative 6. Our answer is the xy coordinate, so 10 minus 6 for y is the xy solution. One more example here, the next one. This time they're both equal to y, so it's kind of weird the way it looks. So we can just take this and plug this top equation basically in place of y in the second equation. And that'll just put variables on both sides. So it'll be negative 1x plus 5 equaling 8x plus 41. And we just solve it like a normal equation with variables on both sides. I usually move the smaller variable to get the positive variable on the right here, 9x plus 41 equaling positive 5. 2 steps from here, I'm going to subtract 41 from both sides. Will give me negative 36 equaling 9x. Dividing by 9 on both sides will give us our answer for x. Negative 4 is x. Either equation again, you can plug this negative 4 into. I'm going to pick the bottom one because there's just no negatives in it. So y equals 8 times the negative 4 plus 41. I kind of regret this choice. I feel like the first one would have been easier. So negative 32 plus 41. So negative 32 plus 41 is going to be our answer there, which is positive 9. A little bit tricky to do that one in your head. So the coordinates for our solution are negative 4, 9. You could, again, use either equation. I could have used the first one. It actually would have been easier because the two negatives are going to cancel here. So y would have been negative 1 times negative 4 plus 5. A negative times a negative is a positive 4 plus 5. And that's actually a little bit easier to do in your head, 4 plus 5 versus negative 32 plus 41. So either way, it's 9, though. As I said, you can plug into either equation in order to get the other coordinate for our solution. So that's 3 examples of how to use substitution in order to solve in a linear system of equations.